Okay, just going to do a little bit of simultaneous equations. I assume you know what simultaneous equations are. You wouldn't have searched for them, or you wouldn't have found them here, or you wouldn't be at this point. You've got two equations with two unknown variables. Let's start with this one. 6h plus d equals 40. 4h plus 3d equals 36. We're going to use elimination the first time. So we need to eliminate one of these variables so we can find the other one, basically. So we're going to focus on the 3 here. We want this d, this amount of d's, if you like, to equal this amount of d's, so then we can eliminate it from the problem. So we're going to, how do we get that amount of d's to equal that amount of d's? Well, what we can do is we can to multiply it by 3. So we take the whole of equation 1 and multiply it by 3, giving us 18h plus 3d equals 180. Take away the second equation and you have 14h equals 84. Solve for h, plug it back in, and you've got it. You've also got substitution. So 3x plus 5y equals 12. 2x minus 6y equals minus 20. Take equation. So we want them to be the same. So how are we going to make this, how are we going to make the y's the same in this instance? Well, think about it a bit like balancing the bottom of fractions when you're summing them together. You can multiply this by the lowest common factor, lowest common multiple, sorry. And this one and the same. So the first thing that we can do really is multiply this one by 6 and this one by 5. So we get 30 in both of them. So you multiply the first equation by 6, multiply the second one by 5, and then you add them together. And that will do away with the 30y, because this is minus 30y. So then you'll be left with the x, solve for the x, and then plug it back in to find y. You can do it by intersection. Start it in there. This rather scribbled drawing here, I'll do this a little bit better, but basically plot both lines, which, as we're doing linear equations, they're both going to be straight lines. It doesn't really matter where they are. Well, it doesn't really matter for this graphic, it doesn't really matter where they are. So you've got equation 1, equation 2, where they meet, that is the answer, basically, where they intersect. Okay, and then in a minute I'm going to do when you have quadratics involved, or non-linear simultaneous equations.